Hello, everybody. So we're going to finish lesson 15.2, the independent practice problems, on page 431 of the 6th grade Go Math textbook for middle school. So let's continue with finding the volume. So number 9, a block of wood measures 4.5 inches by 3.5 inches by 7 inches. All right, so we know again the formula for volume is length times width times height, or the base times the height. Okay, so they tell us it's 4.5 by 3.5 by 7. So basically 4.5 times 3.5 times 7. So we could call this the base, right? So 4.5 times 3.5. So multiply those together. And we should come up with 15.75 times 7. So 110 2500 cubic inches. Okay, remember that the units are important for labeling our answers on these, okay, because cubic refers to volume because there's 3 dimensions. All right, number 10, a restaurant buys a freezer in the shape of a rectangular prism. The dimensions of the freezer are shown. What is the volume of the freezer? Okay. I always like to start with writing the formula just so I can know what I'm plugging in. Okay, so 72.5 times 24.5 times 36. All right, so we can call any of these the base. We can say 24.5 times 36. We could say 72.5 times 24.5, or we could say 72.5 times 36. I'm just going to go ahead and go left to right. So 72.5 is the same as 145 over 2. 72 times 2 is 144, plus the extra 1/2, so 145 over 2. 24.5 is the same as 49 halves, and 36 can be written as 36 over 1. Okay, as I look at these, I notice that I can simplify 49 halves and 36 ones by dividing by a common factor of 2. All right, so let's go ahead and multiply 145 times 49. So 7,105 over 2 times 18 over 1. Well, 2 and 18 can be simplified. So 7,105 times 9. So 63,945 over 1, which is just 63,945. cubic inches. Okay, number 11. Rectangular prism A measures 6 by 4 by 5 inches. Rectangular B's dimensions are twice those of prism A. Find the volume of each prism. Now, when it says prism B's dimensions are twice those of prism, that means not the volume is twice, but each of the individual dimensions is twice as much. So we're going to go 12 by 8 by 10 when we figure out rectangular B, the volume of rectangular prism B. So find the volume of each prism and then tell how many times as great is prism B's volume as prism A. All right, so prism A. So again, start with length times width times height, or base times height. And we have 6 times 4 times 5. Well, I'm going to go ahead and multiply 4 times 5 first. That gives me 20 times 6, and 20 times 6 is 120. So prism A equals 120 cubic inches. Prism B. Okay, now this time, each of the dimensions is going to be twice as much. So twice 6 is 12, twice 4 is 8, and twice 5 is 10. All right, so 12 times 8 is 96, and 96 times 10 is 960. So prism B is 960 cubic inches. So how many times greater is prism B than prism A? Well, I know 8 times 100 is 800, right? So let's try 8 times 120 to see if we get 960. Yes, we do. So prism B is 8 times okay. So prism A came out to 120 cubic inches. Prism B came out to 960 cubic inches. If we multiply 8 times 120, we get 960. So prism B is 8 times as great as prism A. Okay, number 12. A cube has dimensions shown. What is the volume of the cube? How many smaller cubes with an edge length of 1/8 could fit inside the cube shown? All right, so we have 5/8 times 5/8 times 5/8. Okay, so remember, if this whole thing is 5/8 and we're going to fill this with smaller cubes, each of the little cubes would be 1/8 that fills the entire space. So 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. So that's 5 cubes long, 5 smaller cubes. The width would be 5 smaller cubes, and the height would be 5 smaller cubes. Okay, so just keep that in mind after we find the volume of the whole thing. In other words, it's going to take 5 cubes to fill the bottom, 5 smaller cubes to fill the bottom, 5 cubes to fill the whole bottom floor, and then it's going to take 5 layers of those cubes. All right, so 5 times 5 times 5 is 125. 8 times 8 is 64 times 8 would give us 512. So our volume is 125 over 512. And it's going to take us 125 cubes, because what's 5 times 5 times 5? 125. So when we figure this out, again, it's going to be 5 cubes to fill the bottom layer, the bottom front layer, by 5. So 5 times 5 would be the area of the bottom, and we have to multiply it by 5 layers. So 25 times 5, 125 cubes. 13. A company is designing a juice box. The box is in the shape of a rectangular prism. The base of the box is 6.5 inches by 2.5 inches, and the box is 4 inches high. If juice fills 90% of the box's volume, find the volume of the juice in the box. All right, so first thing we need to do is find the volume, right? So in this case, they're giving us the dimensions of the base. And so the base is 6.5 by 2.5, and the height is 4. Okay. So 6.5 is the same as 13 halves, and 2.5 is the same as 5 halves, and 4 is the same as 4 over 1. All right, 13 times 5 is 65. 2 times 2 is 4. So the base is 65 fourths times the height of 4. Well, we can simplify the 4s by dividing by a greatest common factor of 4. So we get 65 times 1, 65, and 1 times 1 is 1, which gives us 65. So the volume of the now it's 90% of 65. It's 90% full, right? So if we go back to proportions, we know that we can write 90% as 0.90. Of means multiply. 65 is how much volume or how much capacity the whole box has. And it's 90% filled. So 58.5 cubic inches. All right, 14. Density is the amount of mass in a certain volume of an object. To find the density in grams per cubic centimeter of a substance, you can use this relationship. Density equals mass in grams over the volume in cubic centimeters. All right, so a gold bar that is 16 centimeters by 2.5 centimeters by 5 centimeters has a density of 19 3/10 cubic centimeters. What is the mass of the gold bar? All right, so let's look at this formula. So I'm going to go ahead and use abbreviations for the formula, where D is the density, equals the mass over the volume. All right, so in our problem, they tell us that the density is 19.3. We don't know the mass, so I'm just going to represent that with an M. And they gave me the dimensions for the bar. So the length, well, it doesn't tell us the length, it just says the dimensions. So 16 times 2.5 times 5. All right. So 16 times 2.5 would be 40 times 5. So the volume is 200 cubic centimeters. All right, so we have to get the variable m by itself. Well, right now it's being divided by 200. So to eliminate the denominator, let's multiply by 200 over 1 and do the same thing to the other side. All right, so why do I want to multiply by 200? Because the greatest common factor of 200, and 200 is 200. So I cross those out, we get 1, right? So we'd have just m on this side, and we'd have 200 over 1 times 19.3 over 1. Which would give us 3,860 grams. All right, 15. A suitcase is a rectangular prism whose dimensions are 1 1/4 by 1 3/4 by 1 1/4. Find the volume of the suitcase. Okay, so start with the volume formula and substitute. So we can say the length is 1 1/4. We can say the width is 1 3/4, and the height is 1 1/4. Again, remember, it doesn't matter which ones we use as the base. Okay. All right, so I'm going to turn these into improper fractions. 4 times 1 is 4 plus the extra 1/4 gives us 5/4. 1 3/4 is the same as 7/4. Again, 4 times 1 is 4 plus 3 more is 7. And 1 1/4 we already know is 5/4. All right. So we can't simplify anything because we have even numbers in the denominators and all odd numbers in the numerator. And the only factors of 4 are 1, 2, and 4. All right, so let's go ahead and multiply straight across. 5 times 5 is 25 times 7. So that would be 175 over 4 times 4 times 4. Well, 16 times 4 is 64. So we have 175 over 64. Turn that back into a mixed number by dividing the numerator, 175, by the denominator, 64. I can't take any 64s from 100. 64 from 1. I can't take any 64s from 17 tens, but I can take 64 from 175. I'm going to try 2. And it leaves me a remainder of 47. So 2 and 47 64ths. cubic feet. All right, let's move on to the next page, page 432. Number 16A. The Smith family is moving and needs to decide on the size of the moving truck they should rent. Okay, so A. A moving van rents for $94.50 per day, and a small truck rents for $162 per day. Based on the amount of space inside the van or truck, which is the better deal? And explain your answer. Well, all right, so 16A, we have to figure out the volume, right? We want to figure out the cost per volume of the van and cost per volume of the truck. So A, so let's go ahead and do van, length times width times height for the van. The van is 10.5 times 6 times 6. The truck was it small truck? Yeah, small truck was 12 times 8 times 6 3/4. All right. And so what we're going to do right now is just figure out the volume of these two vehicles. 10.5 is the same as 21 halves. 10 times 2 is 20, plus 1 more is 21. And I'm going to go ahead and multiply 6 times 6. That's 36, which I can write as 36 over 1. 2 is a factor of 36, so I can simplify that. So we have 21 times 18. So the volume of the van is 378 cubic feet. That's just the size of the truck. We haven't figured out which would be a better deal yet. All right, and the truck. So 12 times 8 is 96, and 6 3/4 is the same as 27/4. 6 times 4 is 24, plus 3 more is 27. All right, 4 is a factor of 96. 4 will go into 96 24 times. So 27 times 24. All right, and so the volume of the small truck is 648 cubic feet. Okay, so now take the price, the cost of both of the vehicles, okay, individually. So here's the van costs $94.50 per day. So how much does it cost per cubic feet? Okay, well, there's no decimals in the divisor, so we're just going to bring the decimal point in the dividend straight up. Okay, I know I can't take any 378 from 94. 378 from 945, probably 2. So we get 189. Bring down the 0. That's close to 400. If that was 1890, that would be about 4. I'm going to try 5 because it ends in a 0. Yep. Okay. So 25 cents per cubic foot for the van. The truck, 648 cubic feet, and it will cost the family $162 per day. All right. So we know that there's a decimal point after this 2. We're going to add a 0 because 648 cannot be taken from 162. All right. There's going to be about 2 of those. All right. So we have 324 left over. But since we have a decimal, we want to keep adding until either our decimal repeats or we get a remainder of 0. Well, 5 times 6 is 30, so that's pretty close to this. I'm going to try 5 again. Okay. Okay, so I get no remainder, and again, it's 25 cents per cubic feet. So which was the better deal based on the amount of space inside? They're the same. Okay. So all I'm doing in A is explaining basically what I did on the paper. So we figured out the volume of the truck and the van. Okay. And then we divided the volume of the vehicles into the cost per day. And we found out that they both came out to 25 cents per cubic foot. So how much greater is the volume of the large truck than the volume of the small truck? Okay, well, so the volume of the small truck is 648 and the van is 378. So how many times greater? Okay, sorry, I'm looking at that. I thought they wanted us to do the same numbers we just did. Just reread that. So we want the large truck and small truck. All right, well, we already know the small truck equals 648 cubic feet. So we have to figure out the large truck. Okay, so the large truck is 20 by 8 3/4 by 8 1/2. All right, so 20 times 8 3/4 is the same as 35/4, and 8 1/2 is the same as 17 halves. Okay, I can rewrite 20 as 20 over 1. I know that 4 is a common factor of 4 and 20, so I can simplify that. All right, so 5 times 35 is 175 over 1 times 17 halves. 175 times 17 . 2,975 over 2. Turn that back into a mixed number. All right, so actually, I'm going to go ahead and use it as a decimal. So the large truck's volume is 1,487.5 cubic feet. Okay, so how much greater is it? Well, we just subtract those two now. So 1,487 and a half minus 648. So 839 5/10 cubic feet more. And C, the family needs about 1,100 cubic feet to move their belongings. What should they rent? Well, if the small truck is 648, let's write them down here. Van. The van was 378 cubic feet. The small truck was 648 cubic feet. And the large truck was 1,487 and a half cubic feet. Well, if they need 1,100 cubic feet to move their belongings, in this one, they'd have to rent 3 vans to get that same 1,100. To get the 1,100 square feet from 648, they'd have to rent 2 small trucks, but they can rent only 1 large truck and have enough room for all their belongings. So I would say they should rent the large truck. All right, 17. A cube has a volume of 1/512,000th cubic meter. What is the cube's edge length? What is its surface area? And explain. Okay, so if the volume is 1 over 512, we need to find a number or a fraction that when multiplied by itself 3 times would give us 512. So okay, so we know the numerator will have to be, I'm just going to put a box here. So I know that the numerator has to be 1, because the only way to get 1 is to go 1 times 1 times 1. Now, how am I going to get 512 by dividing by the same number 3 times? Well, let's just try some numbers. 2 times 2 times 2? Well, that's 8. Oh my goodness, that's way off, right? All right, how about, let's double it. Let's go 4 times 4 times 4. Oh, that's 64. How about 6? 6 times 6 is 36 times 6, 216. How about 8? 8 times 8 is 64 times 8. Okay, that's 512. So it's 8 times 8 times 8. So 1/8, 3 times. All right, so the surface area. So there's 6 faces on a cube, right? And all the cubes have the same area. The area would be 1/8 times 1/8. So the surface area we could find by going 6 times 1/8 times 1/8. So 6 times 1/64. That would give us 6/64. I can reduce by dividing by 2. So 3 30-seconds meters squared. Sorry, not cubed. Surface area squared. Remember, on surface area, we're finding the area of each of the sides and adding them together. Okay. So 1/64 times 6. All right, think about 2 rectangular prisms. One's labeled prism P and one is labeled prism Q. Suppose the bases of the prisms have the same area, but the height of prism Q is twice the height of prism P. How do the volumes compare? Well, let's see. Prism P, prism Q. So they're saying that the bases are the same. All right, let's just say that the base is 4. So right now they're exactly the same, right? Now let's go back to the directions here. It says, but the height of prism Q is twice the height of prism P. All right. So let's say the height of prism P is 2. That means the height of prism Q would be 4. Twice 2 is 4. So 2 times 4 is 8, and 4 times 4 is 16. So the volume is going to be twice as much. Okay, suppose the area of the base of prism Q is twice the area of the All right, so this time they're saying the base is twice. I want to say it's 16 times H, and the volume then, oh, I'm sorry. Okay, so if the base of prism P is 16, prism Q's base would be twice as much, or 32 times H. Well, if H is the same, again, it's going to be twice as much. Right? Let's just say the height was 1. Well, 16 times 1 is 16, and 32 times 1 is 32. So it's going to be twice as much. All right, and finally, number 19. So the dimensions of a rectangular prism are 3 1/4 feet by 2.5 by 5 feet. Lee found the volume by multiplying 12.5 by 3 1/4. Lola found the volume by multiplying 16 1/4 by 2.5. Who is correct? All right, so I'm just looking at this to see what they did. How did Lee get 12.5? Well, he multiplied 5 times 2.5. That would give him 12.5. So he said the base was 5 by 2.5, and the height was 3 1/4. Okay, how did Lola get 16 1/4? Well, she had to have multiplied 5 by 3 1/4 as the base times the height of 2.5. So they're both correct. They're just choosing different numbers to use for the base. In other words, the numbers that they're using are the same. They're just choosing multiplying in different orders, or grouping them differently. So what are they both equal? Well, so 12.5 by 3 1/4. Okay, so if we multiply out what they did, Lee I get 325 eighths, Lola I get 325 eighths. So if we simplify that, it would be 40 5/8. Okay. All right. So again, they're both correct. Okay. Lee just used 2.5 by 5 feet as his base and 3 1/4 as the height. Then he multiplied that base, 12.5, by the height of 3 1/4. Lola used 3 1/4 by 5 as the base and 2.5 as the height. She multiplied her base, which came out to 16 1/4, by the height. Then they both come out to 40 5/8 cubic feet. Right? So that's it for lesson 15.2. So until next time, I will see you soon.